Today we're moving on to two-step equations. This is lesson 3.5. So we're taking everything that we learned from one-step equations, except now there's just two steps. So you are still going to have that golden rule, whatever you do to one side, you must do to the other. We still have the same goal of finding out what that variable means by isolating it, which means get x alone. Inverse operations, we still have addition is the inverse operation of subtraction, and multiplication is the inverse operation of division, and those work vice versa. So inverse operation of addition is subtraction, the inverse operation of subtraction is addition. They go back and forth. We still have our same steps of solving. So just like before, we're going to separate the equation at the equal sign. Make sure that you do that. That tells you that you have a left side and a right side of an equation. It's all about keeping that balanced. So if we separate it at the equal sign, we know we have a left and a right side. You're always going to KCO subtraction. We don't like looking at subtraction. It confuses us a little bit. And so we're thinking about doing the opposite. When I see that there's subtraction there, it kind of gets confusing. So KCO that, now we have a negative number. We're going to do the opposite of the negative, that inverse. Simplify both sides. So we're going to start getting into a little bit of distribution and combining like terms in the future. There's not as much of that today, but that will be happening. We're going to have to circle the variable. That highlights our goal. We have to do that. It tells us that our goal is to get that variable by itself. And then the important thing about two steps compared to one steps is before we either had addition or subtraction, or we had multiplication or division. For a two-step problem, we're going to have both of these. So we're going to either have addition or subtraction, and we're going to have multiplication or division. And we're going to do it in the order that these appear. So we take care of that addition, subtraction first, and then multiplication, division second. So if I know that I have a two-step, I know that it's going to be addition or subtraction and multiplication or division. So keep that in mind. So let's do some Throwback Monday. These are both one-step equations. I want you guys to try these out, see if you get them correct. If you don't get them correct, maybe watch one of the previous videos and email me for a little bit of extra help. So pause the video now, try these two problems. And here are your two answers. So for the first one, you should have gotten negative 27. Make sure you check your answer. For that second one, you should have gotten a positive 30. Make sure you check your answer. So you can pause the screen, check your answers fully, make sure that you got them correct, and see where you got your answer wrong if you got it wrong, because I showed all of my work for these problems. Okay, so we're going to have another Throwback Monday, and this is just over combining like terms. So we're thinking about combining like terms, we're thinking about distribution. Make sure if they have the same variable, you put them together. You're looking at the coefficients. Remember, the coefficient is the number in front of the variable. Also, remember to KCO all of your subtraction. So if you see subtraction, KCO it so you don't get confused. Pause the video, try these two problems. And here are your answers. So for the first one, you should have gotten negative 6D. I KCO'd my subtraction in red here, and then I noticed that all three of these had the same variable of D, so I just pulled out their coefficients. I added them together slowly but surely, and I got negative 6, and then I kept my variable D. For the second one, I showed my distribution by circling the number that I'm distributing and drawing my arrows to each term inside of my parentheses. That distribution is multiplication, so I'm taking negative 8 times y, which we can't do, so we just write them next to each other because that's showing multiplication that we can't do. Negative 8 times y. Then I took negative 8 times 9, and I got negative 72, and I added those two together. And that was my final answer because I can't combine those two. All right, let's get into the stuff for today. So both of these problems are going to be two-step problems. So let's work through this first one together. First thing I'm going to do, as always, is draw a line through my equal sign. My equal sign is right here. Drawing a line straight through all the way down. Next thing I have to think about is KCOing my subtraction. So that's what I'm going to do next. I see subtraction here. Keep, change, opposite. So now we have 3x plus negative 5. Next thing is simplifying. I don't see any simplifying we need to do. That has an x term. That doesn't have any variable at all. And this is just 21 by itself. There's no distribution that I need to do, so I can move on to step 4, which is circling my variable. Now, if you remember from the beginning of this lesson, I told you that we are going to first do addition and subtraction, and then we're going to do multiplication and division. Since I have two things here, I have a 3 and I have a 5, so I've got two different numbers, or a negative 5, sorry. I know that it's a two-step because there's two numbers. I have to get rid of both of those numbers. We always are going to do our addition subtraction first. So if you're not sure which one of these is being added or subtracted, look at your variable x. I know that this is multiplication because they're right next to each other. So I know my multiplication is going to be right here, which means this is the number that I'm adding or subtracting. So we're going to get rid of that negative 5 first. Remember, we want to get that negative 5 down to 0. So if I'm at negative 5, think about what I have to do to bring that back up to 0. And hopefully you're thinking about adding a 5. So negative 5 plus 5 equals 0. Anything plus 0 is just itself. So we're going to rewrite that. But whatever I do to one side, I got to do it to the other. So I'm going to add 5 over here as well. So notice I wrote the same exact thing. I've got a positive 21 plus a positive 5. 21 plus 5 is 26. So we're done with our addition and subtraction. Now we need to move on to multiplication or division. So I know that this is multiplication because it says 3 times x. If there's no sign, then it's multiplication. The opposite of multiplication, or the inverse operation of multiplication, is division. So I'm drawing my division bar. I'm still looking at my variable x. The number that's with that variable is 3. So that's going to be the number that I'm dividing by. 3 divided by 3 is 1, and 1 times x just gives me an x. Now, if I put 26 divided by 3 into my calculator, I'm going to end up with a decimal. So instead of writing down a decimal, and to make it worse, this is going to be a repeating decimal, I'm just going to keep it as a fraction. So I'm going to say 26 over 3. And that's going to be my final answer. We can always check our answer. So what we're going to do is, let me switch my color. We've used red, blue, we'll do purple. So we're checking our answer by saying we have 3 times x. X is 26 over 3. And then we want to use our original problem. So our original problem says minus 5. And we are saying that that equals 21. So if you don't want to do this in your calculator, it's actually pretty easy to do on the side of your paper. So remember, when we're multiplying fractions, both numbers have to be a fraction. So I'm going to say it's 3 over 1 times 26 over 3. This is where that cross simplifying comes in handy. So I'm looking at my diagonals. Both of those are a 3, so I know I can divide them by 3. 3 divided by 3 gives me a 1. 3 divided by 3 gives me a 1. When we're multiplying fractions, we multiply straight across, so 1 times 26 is 26. 1 times 1 is 1. So that just simplifies to 26. And then minus 5 is going to give you 21. And since 21 equals 21, that checks out. So we know that our answer is correct. Now let's try this one. This one's just a little bit different than the other one, but we're still going to follow the same steps. First step, draw our line. I'm going to redraw that line because that's a little wonky. Draw our line. That's not much better, but we're going to go with it. Next step is going to be KCOing subtraction. So I see some subtraction in here, so I'm going to keep, change, opposite. Next step is simplifying, so we're going to combine like terms and we're going to distribute. Hey, look, I see some distribution here. That's what makes this problem a little bit different. So I'm going to take this 3 out front and I'm going to distribute it to every single term inside of our parentheses. 3 times x, can't do, so we're just going to write 3 times x, or 3x. Then plus 3 times negative 4 is going to give me a negative 12. We still have a 9 on the right side, so I'm just going to rewrite that. I can't combine any like terms because this has an x and that doesn't have a variable at all. So this is in simplest terms now. Our next step is going to be circling our variable. So we're going to circle that x. And now I'm ready to actually solve. Remember, 2 steps means 2 different operations that we're looking for. So I'm looking at this and I see multiplication right here. And I'm looking at this and I'm seeing addition here. Again, we always start with our addition subtraction first. So when I'm looking at this problem, I need to get rid of this negative 12 before I can get rid of that 3. So in order to get rid of that negative 12, I'm going to add the opposite. So the inverse of a negative is a positive. So we're going to add a positive 12 to both sides of our problem. A negative 12 and a positive 12 put together equals 0. Anything plus 0 equals itself. So we're going to rewrite that there. Now we've got to simplify that right side. 9 plus 12 is going to give me 21. Now that we've gotten our addition or subtraction out of the way, we're going to move on to our multiplication or division. So I am still trying to isolate that variable. That is my final goal. That 3 is getting in the way. That 3 is being held on by multiplication, so I'm going to do the inverse, which is division. Again, I want to get rid of that 3, so I'm going to divide by 3 on both sides. 3 divided by 3 gives me a 1. 1 times x is x. And then on the other side, we've got 21 divided by 3, which I know is 7. So x equals 7. Let's clear some things out of the way because I don't have any room to check. So let's get an eraser out, and I'm just going to clear everything on this side so we can use this side to check our answer. So if you need this, just rewind the video. So let's go back and check. We've got 3 times the quantity. We've got x. I know x is 7, so instead of writing x, I'm going to write 7. Again, we want to use our original problem. So our original problem said minus 4. And then that equals 9. I'm going to follow the order of operations in order to simplify this side. Order of operations tells me parentheses first. So I'm going to take 7 minus 4 first. Well, 7 minus 4 is 3. I'm going to keep that in my parentheses, and then I'm going to jot down the rest of the problem that I didn't do anything to. Now this says 3 times 3. Well, 3 times 3 is 9. Gonna rewrite that right side, and it says 9 equals 9, which is a true statement. 9 does equal 9, so I know that my solution is correct. So I've just done 2 problems for you. I want you to try these 3 problems by yourself. Notice that this one does have division. What I would do before I get started on this is I know that if I have, let's just put in a number for z. This is not correct. So if I have negative 1/3, that is also equal to negative 1 over 3, and that's equal to 1 over negative 3. Think about if I have a negative divided by a positive, it's going to equal a negative number. So it doesn't matter if you put the negative out front, if you put the negative with the numerator, or if you put the negative with the denominator. In this case, since we've got a 3 on the bottom and a z on top, I'm going to group this negative with my 3 down there. So we'll get rid of that negative there and we'll put it down with the 3 because that's going to make it a little bit easier to think about what number you're multiplying by. You want to multiply by a positive or a negative 3, not a positive 3. So try these 3 different problems. Let me clear this out of the way for you. And remember, you're working with a negative 3 in the denominator. So try these 3 problems and then I'll have the answers for you in a second. Pause the video. And here are all your answers. So for the first one, you should have gotten -4. For the second one, you should have gotten -12. And for the third one, you should have gotten -5. I've showed all my work for all 3 of these problems. So if you've got one wrong, make sure that you go back and double check to see where you had your mistake. I also checked my answers down here so you can see that I'm doing it correctly. And you guys should always be checking your answers as well. If I can do it, you can do it. So now we're going to play a game of right or wrong. So in order to do these, I'm telling you that n equals -12 down here. So you're going to see if Miss Christie is right or wrong by taking that -12 and substituting it into n. So make your prediction now. Is Miss Christie right or wrong that n equals -12? And hopefully you said Miss Christie was wrong. I showed my work over here. So we took that -12 and we plugged it into our n. We substituted it. 2 times -20, oh gosh, 2 times -12 equals -24. And then -24 minus 4. Or if we wanted to KCO it, -24 plus -4 equals -28. -28 does not equal -20. So this is not a solution. It is wrong. Got one more for you? There we go. Is Miss Christie right or wrong? Does W equal 20? Again, plug it in just like how I showed you on that last problem. Pause the video, think about it. And hopefully you said Miss Christie is wrong again, because when we take that 20 and we plug it into our W, or substitute it into our W, we get 4 times 20, which equals 80. We still have to add that -1. When we add a negative and a positive together, our number actually goes down a little bit. So we get 79 equals 81, which is not true. That is not a solution. So Miss Christie is wrong again. Here's your homework for today. It's a little bit more than usual, but hopefully you guys get in the habit of doing everything and you get a lot of practice in today. So here are your homework problems. If you have any questions, please send me an email.